Okay. Raise your hands if number 11 was a point of confusion for you. Okay, that's cool. Okay, I'll just take that as a unilateral yes. That's to the cube, and then I'm going to change these to x's just so that they're hopefully a little more clear. Okay, the problem with this is that you're not used to seeing quadratic techniques when they're given to you in a radical. So you have to know to convert this radical into a fractional exponent. So this is really x to the power of 2 over the root of 3. Right? And that's minus x to the power of 1, right? Good book, by the way, and to the root of 3. Any sophomores in here have to read power of 1? Okay. It's a shame. Equals 0. Now, don't forget about this 5. This 5 has to travel down, and now you have this. So let me go ahead and rewrite this. That way it's a little bigger for you guys. 5x to the 2/3. I don't think that's much better, but that's okay. Minus x to the 1/3 minus 4 equals 0. So now we have our ratio. We have the middle exponent being half the size of the leading exponent, so we're all good. So now, before we do that, I need to rewrite this. X to the 1/3 minus 4 equals 0. I have my parentheses here, and I've got this 5 hanging out. This thing's being squared. What's going to go inside those parentheses? Chris? 1/3. X to the 1/3. And so now, what I have is this thing going on. So I'm going to have a 5x to the 1/3 and an x to the 1/3. Raise your hands if I've confused you. Have I lost anybody? Anybody? Cameron, you good, buddy? Cool. All right, so now all I need are two numbers that multiply to 4. Two numbers that multiply to 4. I don't know. Should we guess? 2 and 2? Well, that's going to give me 10, so no. 10 minus 2 is not going to be it. 4 and 1? That's going to give me 5, and that's going to give me 4. Those can add up to -1. Good. How can they add up to -1? Beth?
5x to the 1/3
Minus 4 plus 1? Something a little bit different? Positive 4, -1. Beth, you want a -5 here. Right? -5, positive 4, -5 plus 4 is -1. Yeah. Okay, so now we're going to split this up. Don't forget the whole thing equals 0. So 5x to the 1/3 plus 4 equals 0. X to the 1/3 minus 1 equals 0. Let's do the easy side first. That's x to the 1/3 equals 1, so x equals 1. This side, I'm going to do the algebra kind of fast. I'm going to get x to the 1/3 equals -4 over 5. Everyone okay with what just happened there? I just subtracted 4 and divided by 5. To get rid of the 1/3, I'm going to cube both sides. So I'm going to get x equals -4 to the 3rd is -64. 5 to the 3rd is 125. All right. Any questions on this problem here? Julia, what's up?
Okay, where you have the 5 and then in parentheses x to the 1/3 and square.
Right here.
How did you get it to 5x to the 1/3?
Oh, because, Julia, if I gave you this problem here, how would you factor that? 5x and x, right? Well, here, it's 5x to the 1/3 squared. So one of them gets a 5x to the 1/3. The other one gets an x to the 1/3. It's the same kind of concept. Since the leading coefficient is prime, there's only one way you can break it up. It's just 5x and x. Except now we just throw the 1/3s on there because that was part of the problem. All right. Okay. Anyone have trouble with that little bro, big bro problem? Number 10? Yeah? Okay. Okay. Good. Good, good, good. That's a good thing. Okay. 8x to the 3rd plus 27 equals 0. Okay, so remember little bro, big bro. 8 is really 2 to the third. X to the third is really x to the third. Plus 27 is really 3 to the third. Now we're going to go little bro and big bro. Little bro gets 1 of everything, so it's 2x plus 3. Now if I use 1 of everything, I used to have 3, and now I've got 2 of everything. Oops. Now I've got 2 squared, x squared, plus 3 squared. So now big bro is going to get the remaining, so it's 4x squared and a 9. Does that ring a bell, everyone? And then to get the middle term of big bro, we multiply the two terms of little bro, so I got 6x. Symbols of symbols of big bro rather are negative, positive, because this is always opposite, this is always positive. And don't forget all that equals 0. Okay, well this is easy. 2x plus 3 equals 0. So x equals negative 3 over 2. That's easy. This one here, remember, as much as you'd like to, this thing can't be factored, so we'll have to use the quadratic formula on it. A equals 4, b equals negative 6, c equals 9. So I've got the quadratic formula. It's negative 6 plus or minus the square root of b squared, so b squared is 36, minus 4 ac is 4 times 9, all over 2a. Let's clean this up a little bit. Negative 6 right here is going to be 6 plus or minus 36 minus this quantity. 4 times 4 times 9 is 144. Oops. 36 minus 144, sorry. Over 8. 36 minus 144 is negative 108. So this is 6 plus or minus the square root of 108. Or rather, negative 108, sorry. All over 8. 108 is the product of two numbers. Those two numbers are negative 36 and 3. The square root of negative 36 is 6i. So this is going to be 6 plus or minus 6i root 3 over 8. And now we can reduce this because they all are even. So this is going to be a 3, this is going to be a 3, this is going to be a 4. So 3 plus or minus 3i root 3 over 2. So those are your answers right there, here and here. Julia. Oh, sorry. Thank you. Over 4. Yeah. Okay, is there anything else from that section that's giving you guys trouble? Max? Can I do 15? Yeah. Okay, this one here doesn't require so much quadratic manipulation. Does anyone know what the leading coefficients in each parenthesis, or not leading coefficients, the leading terms in each parenthesis is going to be? Chris? Y squared, y squared. Now, because the pattern of the trinomial is negative positive, does anyone remember what the pattern on the inside of the parentheses is going to be? If it's negative positive, it's going to be, Devin? Negative, negative. And now all I need are two numbers that multiply to 2. 2 and 1. So y squared equals 2. Y squared equals 1. Don't forget all that equals 0. So y should equal plus or minus root 2. Y should equal plus and minus 1. Okay, we just took the square roots of both sides. Good with that? Is there anything else from that section? Anything else from that section here? Yemisi! 13. All right, Yemisi, I'm going to go ahead and subtract 7b from both sides, okay? Or 7b to the third. So I've got 3b to the fifth minus 7b to the third equals 0. What do both terms have in common? B's. How many? 3. I can pull 3 out of there, so I get 3b squared minus 7 equals 0. So now I set each one individually equal to 0. B to the third equals 0. 3b squared minus 7 equals 0. This is a piece of cake. B equals 0 right here. That's a no-brainer. I'm going to do some algebra here, so it's going to be b squared equals 7 over 3. Take the square roots of both sides, so you get b equals plus or minus root 7 over 3. Your book might give you an answer, b equals plus or minus root 7 over root 3, which they rationalize the denominator, which is plus or minus root 21 over 3. Anything else? Yeah, does that answer your question? Anything else? Julia, what's up? 12. Cool. All right. First thing I'm going to do, Chris, how you doing? I'm going to go ahead and subtract 3m squared from both sides and subtract 5. Sorry, I got to delete this garbage here. So I get 2m to the fourth minus 3m squared minus 5 equals 0. So now I just factor this thing out. Okay, Julia, do you know which one, what the leading terms are going to be? Well, it's 2m and m, right? You know that. But this thing's to the fourth power, so it needs to be split in half. So it's going to be 2m what? Squared. Okay, now all I need are two numbers that multiply to 5. Somehow. 5. Max? Minus 5 plus 1. Let's see if this works out. Negative 5, positive 2. Max, good job. Okay. So now I got 2m squared minus 5 equals 0. M squared plus 1 equals 0. I'm going to add 5 to both sides, so 2m squared equals 5, divide by 2. M squared equals 5 over 2. So we get m equals plus or minus root 5 over 2. The book might have you rationalize the denominator. M squared equals negative 1. Come on. Just joking, right? M equals what? Plus or minus I. Max.
For the quiz, you want to rationalize it?
I haven't decided yet. I might. All right. Anything else? Anything else? I mean, remember, this is your time, so anything else from that section, 8-6. Sean, you got anything? You good? Cameron, you good? You got anything? Chief? All right. I'm going to pause real quick, and then we'll do another round in a little bit. What are all of my factors of the p term? The p term is the final term, right, Chris?
1, 2, 4, 5, 10, 20.
Okay. Now, just so that we get into the habit, what are all the factors of the q term? 1. But because it's over 1, we don't really need to do the p over q thing. Our factors of p are going to be enough. So now we just have to guess. Now, What number do I want to have at the bottom of this?
0.
0. So, let's guess. Who's our resident high-power guesser? Julia, you were always good at guessing. What do you think? 2. Negative or positive? -2. Okay, so now we do synthetic division. This is a 1, this is a -2, this is a -9, this is a positive 18, this is a 10.
Wait, that's actually really weird.
Julia, good job. So, once that works, what do we say? What's the first thing that we do now that we identified one that works? Yeah, Abby?
Get the domain.
No. Max?
Say
X equals -2. Okay. This thing was x to the third. It is now x squared. This was x squared. It is now x. And this was x. It is now nothing. So our new polynomial is x squared minus 9x plus 10 equals 0. Since we're down to x squared, we can probably factor this thing. Negative, negative. 10 and 1? No. Nothing works. This thing can't be factored. It was tempting. So if it can't be factored, then what? Yeah. But because this thing's odd, quadratic formula. A equals 1, B equals -9, C equals 10. So we've got x equals negative b, so I'm going to kind of power through this one, negative b plus or minus the square root of b squared, so that's 81 minus 4ac, so 4 times 1 times 10, all over 2a. So this is x equals negative 9 is positive 9 plus or minus 81 minus 40 is rad 41 over 2. So what we do is we take this thing, gotta love technology. Bam. All right. So that is how you do the P over Q rational zero theorem. Chief, you would have gotten the same answer. Chris, anywhere between 17 and 18. All right.